Wouldn't time travel be amazing? Unfortunately, there's no known way to go back in time like in many, many movies. There is, however, a way to go into the future. This way is called time dilation. Dilation means the action or condition of becoming or being made wider, larger, or more open. So with time, this means that time gets longer. There are two causes of time dilation: speed and gravity. Before I talk about these, I must mention the reason that they happen. Many experiments with light have shown that light moves at the same speed from every perspective. This means that somebody standing still and somebody going at half the speed of light would both see light moving at the same speed relative to themselves. This seems impossible because the person going at half light speed should see the light going at half speed, but this isn't the case. First is speed time dilation. This dilation occurs because as you speed up, the speed of light would end up getting slower from your perspective. To make up for this, your time must move slower so that a slower speed looks quicker to you. There's actually an equation for speed time dilation. With this equation, we can find that the speed time dilation on Earth makes everything run at 99.999915382% speed. You might be thinking, wow, the Earth moves very slowly. This is false. The Earth is moving 10 times faster than any man-made object has gone at 0.13% the speed of light. It's just that light is really fast. Next is gravitational time dilation. This time dilation occurs because light is affected by gravity a little bit. Light is affected by gravity because it has energy, and energy is related to mass. There's an equation for this type of time dilation too. With this equation, we find that the gravitational time dilation on Earth is 99.999930391%. Just like with speed, gravity has to be very, very extreme to have any noticeable effect on time. To find the total effect of time dilation, you have to multiply speed and gravitational time dilation together. After you do this, you find that the total time dilation on Earth is 99.999845774%. This means that one stationary year is 49 seconds longer than a year on Earth. Not a big difference. Another thing about time dilation is that it's exponential. This means that at first the impact of time dilation is minuscule, but near the speed of light or with supermassive black holes, it becomes apparent. Here is an example of noticeable time dilation. A rocket ship is orbiting the supermassive black hole at the center of the galaxy about 1,700,000 miles from the event horizon. To calculate the time dilation, we need to calculate the speed time dilation from orbital velocity and the gravitational time dilation from being near a black hole. First, we need to know how fast the rocket is orbiting the black hole. The equation for this is the square root of the gravitational constant times the mass of the black hole divided by the distance from the center of the black hole. Plugging in the numbers, we get 191,265,585 meters per second, or about 63.8% the speed of light. Next, we put this number into the speed time dilation equation to get about 76.995% speed time dilation. After that is gravitational time dilation. Plugging in the mass of the black hole and the distance from the center of it, we get about 43.088% gravitational time dilation. Finally, we multiply both to get 33.176% time dilation. That would be very weird. If you were on another ship orbiting much further away, you would see a clock on that ship take 3 minutes to make the second hand go around once. The person on that ship would see his clock running normal. This is where we get back to time travel. If the person in the closer rocket stayed for 1 day, then came back to Earth, they would find that around 3 days would have passed. This isn't super incredible, though. But If the rocket adjusted its orbit to 30 feet away from the event horizon, its total time dilation would be 0.002027%. This would make it so that if the person stayed for 1 day then came back to Earth, 135 years would have passed. Now that's time travel. The bad thing is, once you got to the future, you can't come back, unless you created a portal. If you found a way to make a wormhole and took one end with you on the rocket near the black hole, then you would have a way to get back to the past. This is because the portals will both move through time at the same relative speed, so the 1 day for your end of the portal will be 1 day for the other. When you return to Earth, 135 years would have passed, but your end of the portal would be linked to the day after you left. This is how backwards time travel could work. Unfortunately, you can only go as far back as to when the portal was created, so no journey through history. There are more effects of light speed being constant, like length contraction and mass dilation, but that's for a future video. If you have a question about science, leave it in the comments. I'll either answer it in the comments or make a video out of it. Tune in next time for more scientific knowledge.